First of all, question 1. So we are asked to basically solve for x. So first, let's just take the 7th root of both sides of this equation. So basically this, oh not 3, I mean 7. Yes. So that will give you 7x squared is equal to 14x. And then we can divide both sides by 7x to get 7x is equal to 2. And then you can just solve for x, and you'll get 2 over 7. Oops. Oh no. Okay, question 2. Now we are asked to do a counting problem. Okay, so for this problem we will use complementary counting. And basically all you do in complementary counting is you take the total number of possibilities and subtract what you don't want. So in this case, for our total, there are a total of 9 times 10 times 10 times 10 4-digit positive integers. So that is 9,000. And then what we don't want, well, we just don't want any 4-digit integer with the digits 2 or 3. So we just don't want anything with 2 or 3. So basically that will give you, for the first number, you have 7 possibilities, and then 8, 8, 8. So this is equal to 5,004, no. This is equal to 3,584. So we subtract 3,584 from 9,000 to get our answer of 5,016. Question 3, I believe we have done a question similar to this before. So for this first arrangement, this rope will just form a semicircle. It will cover this entire red region. So the area of this red region, well, it's just a semicircle, so we do half times the area of a circle, pi r squared, pi 8 squared in this case, and that's equal to 32 pi. For this next situation, this rope will form a quarter circle like this, and on the other side it will, oh my goodness, it will hit this, the end of this side, and then from here only 4 feet of the rope will continue to move and form a quarter circle. So this green area is just a semicircle plus a quarter circle. Okay, so we already know the area of the semicircle. It's just 32 pi, and then we just want to know what this thing is. So that small quarter circle, it's just, the area is just 1/4 times pi times 4 squared, and this is equal to 32 pi plus 4 pi. So you don't actually have to add this all out, since the question just asks which arrangement gives the dog a greater area. and by how many feet. So we just know that arrangement 2 will give the dog a greater area to roam by 4 pi. Okay, question 4. So Odell and Kershaw are running, and Odell runs clockwise, Kershaw runs the other way. So first of all, we want to find how long it takes for them to run one lap. Okay, so this will be time, how long it takes to run one lap. So for Odell, okay, first of all, we know that distance is equal to your speed times your time. And then that means that we can rearrange this for time to be equal to distance divided by speed. So when we're trying to solve for Odell's time, we can use t is equal to d over s. So Odell's speed is 250 meters per minute. And then the total distance he runs is the circumference of this thing. So we know that the radius of his little track thing is 50. So we do 2 times 50 to get the diameter, and then we multiply it by pi. So that is the distance or circumference. So this simplifies to 2 pi over 5, and that is Odell's time. For Kershaw, we do the same thing, distance over time, speed. So Kershaw's speed is 300 meters per minute. So we put 300 at the bottom. And then his total distance will be the circumference of his little track, which is just 2 times 60 times pi. Okay, so this also simplifies to 2 pi over 5. And yeah, so since both of them take the same amount of time to run one lap, that means that they will, or each time they run a lap, they will meet each other, they will pass each other twice. You can draw a little picture to help visualize. So basically, if they both start from here, they both start at this radial line, and Kershaw will run this way. Wait, no, Kershaw's on the outside. Odell runs this way, Kershaw runs this way. They both meet here, and then they continue running, and they meet again here. So we want to find out how many times they pass each other. So basically, for each lap, they pass each other twice. So knowing that, we just want to find out how many total laps they can run in 30 minutes. So to find that, we just do 30 divided by 2 pi over 5, which is just the speed. How fast it takes for them to run one lap. So this is approximately 23.8. Okay, it's not a whole number, but that's fine. So that means that they will run 23 whole laps, and then each lap they pass each other twice, so we can multiply that by 2. And then for this other 0.8 lap, they will only pass each other once in this time, since they will pass each other at halfway, 0.5. So we can add 1 to this. And then the sum of this is just 46. And that is our answer. Okay, question 5, last problem. So all you had to do was, 47. All you had to do was connect the centers of adjacent faces of a unit cube to form a octahedron. So if you drew a picture, this is what it should have looked like. Okay. So first of all, we want to find the length of an edge. We want to find this length, and this length will be the same for the entire octahedron. Okay. So to find that, we can do the Pythagorean theorem. We know that this is a right angle, and we know that this is just 1 divided by 2, 1/2, and then this is also 1/2. So that means the edge of an octahedron will be square root 1/2 squared plus 1/2 squared. So that is just equal to square root of 2 over 4, or square root 2 over 2. So first of all, the area of a octahedron is, well, we're going to split the octahedron in half so that we get this pyramid. So the area of a pyramid is just 1/3 times the area of the base times half. This B is the area of the base. Okay. So now that we know the length of an edge, we can find the area of this square base. Okay. So our B will just be equal to square root 2 over 2 times square root 2 over 2, or 1/2. Now we just have to find the height of this pyramid. The height will look like this. Oops, that's ugly. So the height of the pyramid is basically just 1/2, since, okay, this is 1/2. The height is going to be 1/2, since the edge of the cube is 1, and the height is just half of the cube. So the height is just 1/2. Now we can actually find the area of the pyramid. Area is equal to 1/3 times 1/2 times 1/2. That will give you 1 over 12. And since we have 2 pyramids in an octahedron, we just multiply 1/12 times 2 to get an answer of 1/6.